So
Sir,
today,
mic is mute.
am I audible?
Yes, sir.
Okay. So today we'll start with our first lecture of this course, Kinematics of Machinery. And of course, we are going to discuss unit number 1, that is fundamentals of kinematics, fundamentals of mechanisms in particular. This is our syllabus for unit number 1, in which I had already told you we have to discuss what is kinematic link, types of link, pair, types of motions, then chain, machine, mechanism, inversions of mechanism, then inversion of 4-bar chain, inversion of slider crank chain, inversion of double and inversion of double slider crank chain. And at the end, we have to discuss concept of mechanisms with higher pairs and then concept of equivalent linkage. So this is our complete syllabus for unit number 1. We'll discuss one by one this all topics. As per university, we have to cover this whole unit in 7 hours. Okay, now we'll discuss one by one. So before starting, I want to ask you a question. What is difference between machines and mechanisms? See, I understand that you already studied this topic in SME. So no need to go in detail. I just try to take from your side what you know, and then we'll discuss accordingly. So we know that when we talk about machines and mechanism, what mechanism is basically, a mechanism is nothing but a combination of number of bodies, or you can say links in particular way, combination of number of bodies assemble in such a way that the motion of one cause constraint and predictable motion of other link is known as a mechanism. So what is mechanism? It consists of number of links, number of bodies assemble in such a way that if I give motion to one link, it will cause or it will cause motion to other link. But how that motion will be? That other link motion is constrained and predictable. Means we can determine its motion. This kind of arrangement is called as a mechanism. Now what mechanism do basically? It transmits and modifies the motion. So mechanism is used only to transmit and modifies the motion. Now what is difference between machine and mechanism? When I talk about machine, it is a mechanism only, or you can say it is combination of mechanisms which apart from imparting definite motion to parts, also transmits as well as modifies the available mechanical energy into some useful work. Means machine consists of number of mechanisms, or it may be a single mechanism. And we know as mechanism is used to transmit the motion, machine also transmit the motion as it consists of mechanism, but along with transmitting motion, it also modifies the available mechanical energy into some useful work. So whenever mechanism is used for, for transmitting available mechanical energy into useful work, we call mechanism as a machine. So what is main difference here? Machine is used to do some useful work, while mechanism transmits only motion. That is difference between machine and mechanism. Now let's say talk about this example. We know this is a slider crank mechanism. This arrow is visible to you.
Yes, sir.
Okay.
Yes, sir.
Okay. So this is slider crank mechanism. Now I call it as mechanism because when I give some motion to this crank, let's say there are 4 elements, 4 links of this mechanism. Before introducing link, I'll call it as a elements, or you can say bodies. So there are 4 links. Let's say link number 1, which may be a frame, link number 2, which is crank, link number 3, connecting rod, and a piston. So what this mechanism do basically, you can see when I give some motion to this link number 2, let's say I rotate this link number 2 by using some motor or some external source. If I rotate this link number 2, this link number 3 transmits motion of this link number 2 to link number 4. And we obtain corresponding reciprocating motion of link number 4. So what happened here? Motion transmission take place. So I can call this as a mechanism, as it is used to transmit only motion. this crankshaft is used to transmit power, or you can say transmit torque. Means what happen when I feed this mechanism in an engine, it transmits or it converts the piston force, force applied on piston to some to torque by crankshaft. Means we obtain torque from crankshaft, and we can run that vehicle, we can drive that vehicle. So what happened here? Useful work is done by that mechanism. Then I can call it as a machine. So I try to told you what is main difference between machine and mechanism. Machine is used to transmit only motion, sorry, mechanism. But in case of machine, we can do some useful work. Is it clear to all? The first concept is clear?
Yes, sir.
Okay. Can anyone tell me now example of machine and mechanism? I just told you with the help of this slider clamp mechanism. Any other example of machine and mechanism? Can you tell me?
Sir, if you consider a bicycle, then the
Okay.
pedal and the sprocket is mechanism, whereas the whole bicycle is machine.
Yes. When you talk about pedal and sprocket, I hope you consider whole arrangement as an entire thing. Means,
Yes, sir.
hello?
Yes.
You have to consider that unit as a mechanism, because mechanism consists of number of elements. Okay, good. Any other example?
So we can give us example of simple clock also. That clock is a machine and all the gears used in inside that is a mechanism.
Can we call clock as machine, or it is mechanism?
Mechanism.
Mechanism. Yeah.
Okay. See, don't get confused. Be relaxed. What I'm saying, just we need to understand here why it is machine, why not it is mechanism. So that thing we must discuss. Can anyone tell me why why we can't call that clock as a machine?
Because it doesn't give any useful work. It just
Yes.
shows time.
Yes. Yes. So it
And
is
no mechanical output.
no mechanical output. Good. Remember, yes, of course, it is not giving any mechanical output and all. So it is considered as a mechanism. Any other mechanism? Yes, please. Good, you're talking. And I request, as it is our first interaction, when you're talking, just you tell me your name, sir, myself, Ganesh, and I want just you can continue. Okay, so I'll understand who is talking, who is interacting. Yes, any other example of mechanisms particularly? Okay, machines, you know, all machines you are using and you know all, but tell me about mechanisms. Yes, any other? See, I'll just give more clarity on the concept mechanism and machine. As I discussed, as someone said, clock. But what we can say about clock, in this case, the force or energy provided is not more than what is required to overcome the friction of the parts. In case of clocks, when we say whatever the force or energy we are providing is not more than what is required to overcome the friction of the parts, and that is used or that is utilized just to get desired motion of the mechanism and not to obtain the useful work. So in that case, it is just transferring motion, not the work, and hence we can call it as a mechanism. Like another example.
So transmission.
Sir, can we call car is a machine and the arrangement that connects the all the four wheels and drives the wheels as the mechanism?
Can you repeat, please?
Sir, can we call the car as a machine and the connecting rods between the tires and the machines which drives the wheels as mechanism?
Connecting rod. You are saying connecting link between the wheels.
Yes, sir.
Yes, it is mechanism only, of course.
Hello, sir.
Yes.
Beam engine mechanism, sir.
Yes, it is beam engine also mechanism. Good. So, okay, I hope you got idea about what basically machine and mechanism is. You can search more about this. Remember, you need to explore it. I just give you idea. Your task is being a mechanical engineering student, being a student of KOM. you should explore this knowledge. You search on internet, you search on Google, okay, what are the examples of machines, what are the example of mechanism? So you'll get more idea about that. Okay, now before starting basic fundamentals of mechanism, we need to understand some motions. In diagram, there are, you can see these are some diagrams are drawn here. We discuss types of constraint motions. Which are the types of motions? Basically, which are the constraint motion? Now, why it is essential to study constraint motion? You'll come to know later on. Let's focus on this topic, types of constraint motion. Basically, when I talk about motion and constraint motion, there are three types of constraint motion. One is completely constrained motion. Then second one is incompletely constrained motion. And third one is successfully constrained motion. So if you see in this diagram, first diagram, here one prismatic bar is there, and that prismatic bar is allowed to move inside this prismatic hole. Prismatic means rectangular, you can say. So tell me, in how many directions this motion of this bar inside that another bar is possible?
Two directions,
Which two directions?
forward and backward, or we can say right or left.
So right or left, or you can say forward, backward. But can I say it is only one direction because it is only along x axis? Let's say if I call it as let's say in x direction, it is possible in only one direction. Are you getting what I'm saying?
Yes, sir.
Okay. So remember, when the motion between two elements of pair is in a definite direction, irrespective of direction of the force applied. I repeat, when motion between two elements of a pair, let's say these two elements are here, 1 and 2, if motion between them of that pair takes place in a definite direction, that motion is called as a completely constrained motion.
Sir, your voice is breaking.
Bar slides inside the other bar, prismatic bar. So here one sliding motion possible in only one direction, sliding motion, and it is predictable. We know we can't rotate this bar because of this arrangement. So we can only slide it. So hence it is called as a completely constrained motion. Now take example of this. There is one rod, maybe a circular rod, and it is allowed to rotate inside a circular hole. But at the end, there are some caps are provided here. So tell me, this bar, for this cylindrical bar, how many motions are possible?
Two motions.
Which two motions?
Rotational motion and linear motions in one
Yes.
direction.
Of course. But remember, yes, there is rotational motion possible as it is hollow, it will rotate. But as these ends caps are provided here, it is not allowed to move. You can see second diagram here. Here the two motions are possible. This arrow is visible. Hello.
Yes, sir.
Yes.
Okay. So here two motions are possible, but here it is not possible because some restrictions are provided here. So in this case, only one motion is possible. That is only rotation. Understand? So here as only one type of motion, it takes place in one definite direction. Hence, this motion also called as a, yes, completely constrained motion. We are discussing types of constrained motion. The first type is completely constrained motion. Here it takes place in only one direction. Hence, in the first two example, we call it as a completely constrained motion examples. Now let's talk about this example. Here now, the motion is possible in two directions, in two ways. It can rotate as well as it can slide, depends upon force applied. So tell me, so in that case, in this case, whenever motion between two elements of a pair is possible in more than one direction and depends upon direction of force applied, it is known as a incompletely constrained motion. Understand?
Yes.
Yes, sir.
Okay. Hello. Two types are clear.
Yes, sir.
Okay. Now third type is successfully constrained motion. We discuss about completely constrained motion, then incompletely constrained motion. Incompletely means, yes, incompletely means completely constrained motion means take place in only one direction. But incompletely means it can take place in more than one direction. It is possible in more than one direction. Okay. Now, last one is successfully constrained motion. In successfully constrained motion, let's take example of this. Now, if this load is not applied here on this bearing, actually it is one footstep bearing example. If this load is not there, then this shaft can rotate, as well as which kind of motion it has? It may have. If this load is not there, assume that this load is not there, then it can, if we apply force, if we rotate this, it can rotate, as well as we can move it linearly. Understand? So means there are two motions possible initially when this load is not there. But when we apply some load in a vertical direction, now tell me in how many directions, how many motions possible here?
Only one linear.
Only one linear possible. Is it linear possible? Because we are applying load from upper side, so it is not allowed to move upward or downward. So only rotation possible here. Means what? When the motion between two elements of a pair is possible in more than one direction. Actually, it is possible in more than one direction. Yes, it can linearly move or it can rotate, but it is made to have motion only in one direction by using some external means. Then that motion is called as a successfully constrained motion. So when motion is possible in more than one direction, but by applying some external means, we restrict that motion of one direction, and now it is possible motion in only one direction, then that motion is called as a successfully constrained motion. Means it is constrained motion, but it is successfully constrained. Successfully means we apply some efforts to make it constrained. So there are three types of constrained motion I discuss here. One is completely constrained motion, other one is incompletely constrained motion, and third one is successfully constrained motion. Clear this?
Yes, sir.
Yes, sir.
Yes. So I hope it is clear. Can anyone tell me types again so that I'll get confidence that you are getting?
Completely constrained motion, incompletely constrained motion, and successfully constrained motion.
Very good. So these three types we discuss, that is nothing but types of constrained motion. Okay. Next topic now. Before going for link and all, we need to discuss about rigid and resistant bodies. As we know, as I told you, our prerequisites are engineering mechanics, engineering physics, engineering mathematics. But in mechanics, you might seen this concept. And you know that because mechanics, basically it is nothing but whatever mechanics you learn, it is your rigid body mechanics. So tell me, what is rigid body first? When you call body as a rigid body?
Body which does not deform after application of load, external load.
Yes, does not deform. It's called as a rigid body. Good. So what is rigid body basically? Or you can say, under the action of forces, it does not suffer any distortion, or distance between any 2 points on it remains constant. It's called as a rigid body. The body which does not undergo any deformation, basically under the action of forces, is called as a rigid bodies. But there is one more concept called the resistant bodies. Now, what these resistant bodies are? Now, we can say resistant bodies are those bodies which are rigid, but not always. I'm saying these are rigid for the purpose they have to serve. Means for under some particular, for a particular time, they act as rigid bodies, even though they are not rigid bodies. Example, I'm discussing. These are not rigid bodies, but basically resistant bodies are not rigid bodies, but these bodies which are rigid for the purpose they have to serve. For some time, they will act as rigid bodies. So along with that, apart from rigid bodies, there are some semi-rigid bodies which normally flexible, but under certain loading conditions act as a rigid bodies for the limited purpose, and thus they are called as a resistant bodies. Example, you can call about a belt. We know belt is not a rigid body, but belt will act as a rigid body when it is subjected to tensile force. You know that if I consider any belt and if you apply some force, then if I apply some compressive force on a belt, then will it act as a rigid body? You know, tensile and compressive. I hope you studied strength of material. Okay, so if
Yes,
you
sir.
consider a belt between two hands and apply some compressive force, then will it act as a rigid body?
No.
No.
No, sir.
No.
But instead of that, let's say I apply some force, a tensile force. Yes, it may act as a rigid body. You're getting what I'm saying? So in that case, belt which is not rigid body will act as a rigid body under the tensile force. So that body is called the resistant body. Another one example, you can say also fluids. When fluids are subjected to compressive force, it will act as a, yes, it will act as a resistant body because it will resist their compression. So resistant bodies are those bodies which are not rigid bodies, but they will act as rigid bodies for the purpose they have to serve. And so understand, consider a resistant body.
Yes, sir.
Okay. We can also discuss some, for some purposes, springs are also act as a resistant bodies. So I discuss example of belt, then fluids, and I told you for some purpose, the springs can also act as a resistant bodies. But generally, these resistant bodies are referred as a rigid bodies, even though they're not. Okay. Anyone can tell me other example of resistant bodies? Maybe this is new concept for you.
I'm just trying. We have seen the PMPs in that near the suspension there is one tire placed. It may be as act as a resistant body.
Okay. So for that purpose, maybe at that time for doing that purpose, it may act as a resistant bodies. Good.
Yes.
Yes. Then I can call it as a rigid body. Sorry, resistant body. Now after this, if you know the concept of link, if you know the concept of resistant body, you understand resistant body, then we are going to define one more concept which is important, that is nothing but a link. I hope it is known to you. So when I talk about machine and mechanism, we can say each part of the machine, or we can say mechanism, which moves relative to some other part, is known as a kinematic link or simply a link. So we can say a part of mechanism or a part of machine which moves relative to other, which have some relative motion with respect to other part, is known as a kinematic link. But remember, in other words, we can also define like this: a resistant body or a group of resistant body with rigid connections preventing the relative movement is known as a link. Now, I hope you don't understand this, but remember, to call any part I can call it as a link with two conditions. First thing, it must be a resistant body. Keep this in mind, even though it is not written on the slide. And I request everyone, when you are discussing, you may write your own notes. So remember, for a body to call as a link, the first thing is we can call it as it must be a resistant body. It must be a resistant body. And now what is resistant body? That already we discussed. That link must be a resistant body, first thing. Second, as discussed here, it must have some relative motion with respect to other part. So there must be a relative motion. So when a body is a resistant body and it has relative motion with respect to other part, with respect to other body, then that body or that part you can call as a link. Is it clear? When you can call any part of the machine or mechanism as link, two conditions must be satisfied. One is it must be a resistant, and second thing, there must be a relative motion with respect to other parts or other bodies. Is it clear?
Yes, sir.
Yes, sir.
Okay. Generally, in oral, some questions are asked based on this topic to check your knowledge, whether you understand basically the concept of link or not. In that case, they will check if examiner is want to check in a proper way. He will give you example such a way that you must think first whether it is resistant body or not. Then only it can be called as a link. Now, can you tell me? Okay, we'll discuss this first, then I'll go for examples and all. So there are different types of links. One is rigid link, flexible link, and fluid link. Now, what is rigid link? A link which does not undergo any deformation. As of course the name is rigid only, and we know that in rigid there is no deformation. So when a link does not undergo any deformation, it's called as a rigid link. The next one is flexible link. And the flexible link is that link which partly deform in a manner not to affect the transmission of the motion. Example is belt. So you know that belt is partly deformed sometimes to affect the in a manner not to affect the transmission of motion. So belt, ropes, then chains and wires are the example of flexible link. They are flexible, but they will transmit the motion, and they will have relative motion with respect to other. Of course, they will act as a resistant bodies to transmit their force, to transmit their motion. So another one is flexible link, which partly deform in a manner not to affect the transmission of motion, is called as a flexible link. So we discussed rigid link, which does not deform. Flexible link deform partly, and the last one is fluid link. So what is fluid link basically? Which is formed by having a fluid and transmit the motion by fluid pressure or compression. So if the mechanism consists of a fluid link, means it is formed by having a fluid, there will be some fluid element, and transmit the motion by fluid pressure or compression. An example you can see in case of a hydraulic press, lifts, we can say jacks and brakes of automobile. These all examples are known to you. In all cases, fluids are used. So that fluid elements are considered as a link, because in disc brakes, disc brakes, you can say the fluids are used to operate the brakes. So in that case, it acts as a link. Means the fluid can also act as a link. Don't think always it must be a rigid element, some metal element. It may be a fluid also. So this we discuss types of links. What is rigid link, flexible link, and then fluid link. Any doubt about this?
Also.
No.
Sir, shock absorber falls under flexible link or fluid link?
Yes.
Shock absorbers.
Now see, when we talk about shock absorber, first we can say, is it a mechanism or a pair of mechanism?
No.
Yes.
Okay, let's complete. Okay, I'll give you answer, or you may get your answer on your own. Once we complete the what is link, pair, mechanism, or you can before that kinematic chain, and then mechanism. Okay. So that is just simple terms we are discussing, types of links and all. But what point I want to highlight here, a link can be a fluid link, or it may be a flexible link, or it may be rigid link. And of course, we'll discuss about your topic, whether shock absorber, what was your question? Whether shock absorber is a
Shock
fluid link or
absorbers
not?
falls under fluid link or flexible link.
Yes. Okay, we'll discuss that. Don't worry. Any other? And I request you just come up with questions. We'll try to solve your questions, so that you see he asked the question. So means others will get that may get clarity on the topic. So I encourage you to ask the questions.
So can we say that coolant may act as a fluid link?
Coolant may act as a fluid link. Of course, that part will act as a link. Okay, in that mechanism. Even whenever there is fluid, see, we are transferring in all these cases we discuss hydraulic press, lifts. That fluid portion will act as a link, because it is transmitting motion from one part to another part. So whenever that element is used to transmit motion from one part to another part, it is considered as a link. And now which type of link it is? It may be rigid, it may be flexible, it may be fluid. Depends on how we transmit that motion. I think this is again answer to your question also, previous question, whether shock absorber is fluid or flexible. When you call link is used to transmit, if it is in a mechanism only, it is used to transmit motion from one element to other. First thing. And now how we transmit the motion? By rigid way, flexible way, or by fluid way? Means only fluid. Flexible means, remember, flexible link is not a fluid link, remember. So when you talk about shock absorber, and shock absorber is transmitting by means of oils, okay, so it will be considered as a fluid link. Flexible means the nature, like you can say rope or a belt or a chain or wires, they are flexible in nature, but they will transmit when they are transmitting their motion, they will not act as a flexible link, but they will act as rigid bodies. That links are called as a flexible link, and the fluid link means fluid elements are there. And of course, when there is fluid, they will transmit motion only when under the pressure or compression, not in any other case. So these are the three examples of links, that is rigid, flexible, and fluid link. Now types of rigid links. I talk about rigid link. What is rigid link? Can you repeat, anyone?
The link which cannot deform.
Yes, it will not deform under the action of forces. That link is called the rigid link. Now, depends upon the point at which this link is attached in a mechanism. The rigid links are classified into three types. You can see the first one here. Here, this link is there, and this link has two connections. Means I can connect this link to another link at 2 points. Let's say here, this is one connection for attachment to other link, and this is another connection. As this link has two connections at which I can connect this link to another links, so this link is called as a binary. Binary means two. So it depends upon the point at which link is attached in a mechanism, in a pair, is called as a, these links are classified. So these rigid links are classified based on the point at which these links are attached to mechanism. So based on point of attachment, how many points are there, at how many points I can connect this link to other link. Based on that, we classify it as a binary, ternary, and quaternary link. So ternary means there are three attachments, 3 points are there. One, here I can also connect, here or here. So binary, ternary, and quaternary are the 3 points at which I can connect this link. Hence, this link is called as a ternary link. In quaternary link, there are 4 points at which I can connect this link to another link. So based on points at which we can connect the particular link to another link, these links are classified into 3 types: binary link, ternary link, and quaternary link. Is it clear?
Yes, sir.
These are just simple concepts you understand. Okay, I hope it is clear. Types of rigid link. But remember, this is and when I'm classifying this, of course, I consider it as a rigid links. So there are 3 types of rigid links. Depends upon at how many points they are attached to another links: binary, ternary, and quaternary. Now we'll talk about a pair. Now, when a pair is formed, basically, when 2 links or elements of a machine, when in contact with each other, are said to form a pair if relative motion between them is completely or successfully constrained motion. Now you might maybe confuse why, sir, you take concept of constrained motion earlier, because I want to explain here. When you are going to define pair, kinematic chain, mechanism, you must know what is constrained motion. Now anyone tell me what is constrained motion first before pair now? What do you understand by the term constrained motion? Already we discussed its types and all. When we called motion is constrained? Yes?
When the motion between two elements is in definite direction.
Yes. When it takes place in definite direction, then it is called as a constrained motion. And we also know types of constrained motion. Which 3 types we seen?
Completely constrained, incompletely constrained, and successfully constrained.
Okay, good. So we know that the motion is constrained. What is constrained motion? So when we called, what is basically a pair generally? When 2 links, let's say this is one link and it is another link, and I connect these 2 links at one joint here. Okay. Now can I call this joint as a pair, or these 2 links are said to form a pair? Yes, I can call it as pair only if it satisfies some conditions. What the conditions are? I repeat here. See the basic definition I written here. When 2 links, let's say it is link 1 and it is link 2. when two links or elements of a machine, of course, they are considered as a part of machine or mechanism. When two links or elements of machine, when in contact with each other, are said to form a pair if relative motion between them is completely or successfully constrained. It is not incompletely, remember. Either it must be a completely or successfully. It takes place in definite direction. There is some definite motion. There is some constrained motion. And if these two elements are connected in such a way that there is completely or successfully constrained motion, then I can call it as a pair. So pair is formed between link 1 and link 2. So pair is nothing but a combination, a joint of link 1 and 2. Don't call it as joint, because joint in a pair, there may be different joints. Okay. So we called here.
There may be hinge joint also.
Yes. And of course, here it is turning joint. You can say revolute joint is here. About joint we'll discuss later. Let's define pair only. So I repeat here what is pair. A kinematic pair or a simply pair is joint of two links having relative motion between them, simply. Understand? Kinematic pair or pair is called as a joint of two links having relative motion between them. There must be a relative motion. If I consider, let's say, I consider this one link and I join with another link. And I welded these two links together. I said I welded these two links together. Initially, it is link number 1. It is link number 2. So can I call this as separate links? Initially, I consider one body 1, another body 2, and I join them. I welded them. So can I call this as pair?
No, sir.
Why not?
Because there will be not the relative motion.
Yes, that is important point. There should be a relative motion between two bodies. Now see, when you said it is not a pair, can I call it as a, how many links are here now in this case example? Can I treat it as two links?
One.
What is link basically? How we define link? Link is a resistant body which have relative motion to others with respect to other link. Remember, a link must have relative motion with respect to other link. And if it does not have relative motion, then it is not a separate link. Example I'm talking about. Let's say here. Let's say called about this one. Okay. How many links are here?
3.
Yes. How many links are here? Yes. How many links? 1, 2, 3. Hello.
Yes, sir.
How many links?
3 links.
Yes. It is only one link. Why? Because there is no relative motion between these parts. It is act as a single unit. Are you getting? So at this joint, let's say there are welded joints. So it is a triangle basically. And there is no relative motion between this. Let's say part A, I'm saying A is a part, B is another part, and this C is another part. So A, B, C is not having relative motion with respect to each other. If this A with respect to B or with respect to C is having relative motion, then only I can call it as a separate links. But there is no relative motion between A and B. There is no relative motion between A and C. Also, there is no relative motion between B and C and A and C. So if there is no relative motion between the different parts, then it forms as a single link. Are you getting point?
Yes, sir.
Okay. In this case, now tell me, I told you these are welded together. So how many links are these? Let's say part 1 and part 2, I'm saying. Welded together. No relative motion between them. How many links are these?
Single link.
It is a single link. Are you getting? But when I said there is one part 1 and part 2 are connected together by means of a turning pair, there is relative motion between 1 and 2, then I can call it as a pair. Understood? So there must be a relative motion between the two. Then only I can call it as a pair of the elements, and these two can be treated as a separate links, not a single link. I hope you understand the concept of link and pair. Yes? Any doubt? Any doubt?
No, sir.
No.
Okay. Getting what is link and pair? Please reply.
Yes.
Yes.
Okay. Now see, last concept I will take and then we'll stop. The next one is, now I told you what is pair. Okay, if there is relative motion between them, between the links is completely or successfully constrained, then I can call it as a pair, or you can say kinematic pair. Now these pairs are classified depends on different parameters, but one parameter is there based on nature of contact, how that two links are connected together. What is nature of contact between the two links? These pairs are classified in two types. One is lower pair and other one is higher pair. What is lower pair and higher pair? If there is, we can say lower pair and higher pair. If the two links are connected together having surface or area contact, then that pair is called as the lower pair. But if the links which are connected together having point or line contact, then it is called as a higher pair. Okay, we may discuss this in detail in next lecture, but okay, just you can discuss here. There is point contact. If there is point or line contact, then that pair is called as a higher pair. But if there is surface or area contact, surface contact or area contact, then that pair is called as a lower pair. Can anyone tell me example of? Okay, I will tell you some examples. You tell me whether it is lower or higher pair. Let's say a wheel rolling on a surface.
Lower pair.
Higher pair.
Wheel rolling on a surface. When wheel is rolling
Higher
on a surface, which type of contact is there between wheel and that surface?
Point.
Line contact. Line contact. Let's say this is wheel is
Line
there.
contact, sir.
Okay, this wheel is moving.
Higher pair.
Wheel is moving over a surface. Here, we know that there is some width of the wheel, na? That we need to consider. Okay. So what happened here? There will be a which type of contact here?
Line.
Higher pair.
Line contact. So line contact means it is a higher pair. Example, other example, you might see in gears. When two gears are in mesh, let's say two spur gears are in mesh, which type of contact they are having? Actually,
Surface.
for different gears, different types of contact is there. Okay, but let's say take example of spur gear. In case of spur gear, which type of contact is there between two gears?
Point contact.
Line contact. And if it is line contact, it must be a higher pair. So gear is one example of a pair. Keep in mind. Another example, I'm talking about a lower pair. Let's say a nut turning on a screw. I hope all of you know nut and screw and all. So nut turning on a screw. Which kind
Surface
of?
lower pair.
Because the surface contact is there. Okay. In case of slider kind mechanism, a piston sliding inside a cylinder. Here also we talk about these examples. Let's say I told you at the time of constraint motion, I told you this example. This prismatic bar is sliding inside the other bar. So which kind of pair is this? Yes. It is lower or higher pair?
Lower.
Lower.
It is lower pair. Okay. So I hope you understand difference of lower and higher pair.
Yes, sir.
Yes, sir.
Okay. So I think we have to stop here as the next lecture is there. So what we discussed today, just small part we discussed today. We started with what is machine and mechanism. Then I given you some examples. Then we talk about types of constraint motions. Then what is considered rigid and resistant bodies. Then link. When a part, when it is called as a link or kinematic link. Types of links. Then types of link we discuss. Types of rigid link we discuss. After that, I introduce you definition of pair, and then types of pair. This is what we discussed today. I hope it is clear to all.
Yes, sir.
Okay. Now I share already Google form. In that Google form, you have to submit just for attendance purpose. You have to submit that Google form. As well as I will monitor attendance from Google Classroom also. Sorry, Google Meet also. We'll meet in next lecture. Okay. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
PPTs.
Thank you, sir. Bye, sir.